The universe is big, really, really big. There are more stars in space than grains of sand on every beach on Earth. Around those stars, there are planets, billions and billions of planets. Some of these planets are like Earth. They have water, they have the right temperature, they could have life. We've been looking at the sky for years. We've sent messages into space. We've listened for signals. We've found nothing. Not one sign of alien life. Not one radio signal. Not one spaceship. Nothing. This problem is called the Fermi paradox. It might be the most important mystery humans have ever faced. In 1950, a scientist named Enrico Fermi sat down for lunch with his friend. They were talking about flying saucers and aliens. Everyone was laughing and joking. Then Fermi stopped and asked, "Where is everybody?" It seemed like a joke at first, but Fermi was serious. He started doing math in his head. The universe is about 40 billion years old. Our galaxy has hundreds of billions of stars. Even if life is rare, there should be thousands of alien civilizations out there. Some should be millions of years older than us. They should have spread across the galaxy by now. But we see nothing. We hear nothing. We are alone as far as we can tell. The map says aliens should exist. The silence says they don't. Our sun is one star. In our galaxy, the Milky Way, there are between 200 and 400 billion stars. The Milky Way is just one galaxy. We can see about 2 trillion galaxies with our best telescopes. Each one has billions or trillions of stars. The numbers are so big, they stop making sense. Imagine every star in our galaxy is a grain of sand. You would need 10,000 dump trucks to carry all that sand. We used to think planets were rare. We're wrong. New science shows that almost every star has planets. In our galaxy alone, there might be 40 billion Earth-sized planets in the habitable zone. The habitable zone means they're not too hot and not too cold. They're just right for liquid water. Water means life is possible. 40 billion chances for life. Just in our galaxy, there are trillions of galaxies. Even if life is incredibly rare, it should exist somewhere. Even if smart life is incredibly rare, it should exist somewhere. Even if space-traveling civilizations are incredibly rare, there should be at least a few out there. We've been listening for alien signals since 1960. Scientists point radio telescopes at the sky and listen. They're looking for patterns. They're looking for signals that nature couldn't make on its own. After more than 60 years, they found nothing. We've also been sending our own signals into space. Every radio show, every TV broadcast, every radar signal, they all leak into space. They travel at the speed of light in all directions. Any civilization within 100 light years of Earth could pick up our signals if they're listening. That's thousands of star systems. We've sent some messages on purpose too. In 1974, scientists sent a radio message from the Arecibo telescope toward a cluster of stars. It would take 25,000 years to get there. In the 1970s, we put golden records on the Voyager spacecraft. These records have music, pictures, and sounds from Earth. They also have directions to find us. No response, no signal, no sign that anyone else is out there. The universe seems empty of intelligent life. Scientists call this the Great Silence. In 1961, a scientist named Frank Drake made an equation to estimate how many alien civilizations might exist in our galaxy. The equation looks at several things. How many stars from each year? How many of those stars have planets? How many planets can support life? When Drake first did the math, he got a number between 1,000 and 100 million civilizations in our galaxy. Even the low end means they should be visible. Today, we know more than Drake did in 1961. We know planets are common, we know the building blocks of life are everywhere in space. We know life started on Earth pretty quickly after the planet cooled down. All of this makes life seem more likely, but the equation has one part we can't measure. How long do civilizations last? Maybe civilizations destroy themselves quickly. Maybe they only broadcast signals for a few hundred years before they stop or disappear. The galaxy could have had thousands of civilizations that came and went. We just never existed at the same time. There might be something out there that kills civilizations, something that might kill us too. Scientists have suggested many solutions to this mystery. The first idea is called the rare earth hypothesis. Maybe Earth isn't typical. Maybe we're special in ways we don't realize. Yes, there are billions of Earth-sized planets in habitable zones. But having the right size and distance from a star might not be enough. We have a large moon. Our moon stabilizes Earth's tilt. Without it, the climate would swing wildly. Seasons would be extreme. Complex life would be harder. We have Jupiter. Its gravity pulls in comets and asteroids that might otherwise hit Earth. Jupiter acts like a shield. We have plate tectonics. Earth's surface moves and shifts. This recycles carbon and keeps the climate stable over millions of years. Not all planets work this way. We have a magnetic field that protects us from dangerous radiation from the sun. Mars lost its magnetic field billions of years ago. The solar wind stripped away most of its atmosphere. We are in a safe part of the galaxy, not too close to the center where radiation and supernovas are common, not too far out where heavy elements are rare. Maybe all of these things need to line up perfectly for complex life to develop. Maybe Earth is 1 in a trillion. We might be alone in our galaxy. We might even be alone in the universe. Another idea is called the Great Filter. There is a step in evolution that's extremely hard to pass, almost impossible. This filter stops life from becoming a space-traveling civilization. Where is the filter? Maybe the filter is behind us. Maybe the hard step was the start of life itself, or maybe it was the jump from simple cells to complex cells that took billions of years on Earth. Maybe it almost never happens. If the filter is behind us, we're lucky, we made it through. But maybe the filter is ahead of us. Maybe something stops civilizations before they spread through the galaxy. Nuclear weapons could do it. Climate change could do it. Artificial intelligence could do it. Some technology we haven't invented yet could do it. The silence might be a warning. We've come close to nuclear war before. During the Cold War, there were several times when nuclear war almost started by accident. We got lucky. Maybe other civilizations don't get lucky. Maybe every industrial civilization burns fuel, warms their planet, and makes it unlivable before they can escape to space. Maybe every civilization creates AI that's smarter than them, and maybe that AI decides its creators aren't needed. We don't know what the filter is, we just see the result, an empty sky. Maybe aliens exist, but they're deliberately hiding from us. Scientists call this the zoo hypothesis. Think about how we treat animals. We have nature preserves where we watch animals but don't interfere. We have rules about contacting isolated tribes. We want to observe without disrupting their natural development. Maybe aliens are doing the same thing to us. Maybe there is a galactic law that says young civilizations should be left alone. Maybe they are watching us, studying us, waiting to see what we become. But there are problems with this idea. It only takes one civilization to break the rules. If there are thousands of civilizations out there, surely one of them would try to contact us or would slip up. We might be giving ourselves too much credit. We assume we are interesting enough to watch. But to a civilization millions of years old, we might be like ants. Most people don't spend years watching an anthill. Another version says aliens can't travel here because the space is too big. The nearest star is 4 light years away. That's 40 trillion kilometers. Even traveling at 10% of light speed, which is incredibly fast, it would take 40 years to reach us. Maybe no civilization has figured out how to travel between stars. Maybe the speed of light really is a hard limit. Maybe space is full of civilizations that can't reach each other. They are all stuck in their own solar systems. The universe might be full of life that we'll never meet. Maybe we're looking at timing, not a mystery. The universe is 40 billion years old. That sounds old, but stars can last for trillions of years. We're actually very early in the universe's lifetime. Complex life needs heavy elements like carbon, oxygen, and iron. These elements didn't exist at the start of the universe. They were made inside the stars. When those stars exploded, they spread these elements around. New stars and planets formed from this enriched material. Earth formed about 4.5 billion years ago. That's about 9 billion years after the Big Bang. Could planets with life have formed much earlier? Maybe not. Maybe the universe needed those 9 billion years to build up enough heavy elements. If Earth formed relatively early in the window when life is possible, we might be among the first. We might be the first intelligent life in our galaxy. In millions of years, our descendants could be the ancient aliens that other species wonder about. This makes us incredibly important. The future of intelligence in the universe might depend on us. If we survive and spread through the galaxy, we could be the ancestors of countless civilizations. But it also means we are alone right now. There is no one to learn from, no one to guide us. Some people think aliens are already here. They point to UFO sightings and strange objects in the sky. In recent years, the US government has admitted that pilots have seen objects that move in ways we can't explain. These objects are real. They show up on multiple sensors, but that doesn't mean they're aliens. Unknown doesn't mean alien. These objects could be secret military technology. They could be natural phenomena we don't understand yet. They could be sensor errors. Alien spacecraft would need to break the laws of physics as we understand them. They would need to accelerate instantly without crushing the pilots inside. They would need energy sources we can't imagine. They would need to travel faster than light to get here. All of this is possible technically. Our understanding of physics isn't complete, but it requires believing that aliens are so advanced they seem like magic. And if aliens are here, why are they hiding? Why haven't they made official contact? Most scientists don't think this solves the mystery. This mystery has real meaning for humanity's future. If the great filter is ahead of us, we need to be very careful. Every new technology could be the thing that ends us. We need to think hard about artificial intelligence, genetic engineering, and nanotechnology. We need to avoid nuclear war and climate disaster. If we're alone or if we're first, we have enormous responsibility. We might be the only conscious beings in the galaxy. If we fail, the universe stays dark and empty. Some scientists say we should stop sending signals into space. If hostile aliens exist, we shouldn't tell them where we are. Other scientists disagree. They say the galaxy has had billions of years to develop civilizations. If hostile aliens exist, they would already be here. The fact that we're still alive means either there are no aliens or they aren't interested in conquering us. This mystery also affects how we think about space exploration. If life is rare, every planet with life is precious. We need to protect Earth. We also need to spread to other planets, not to find aliens, but to back up humanity. If something happens to Earth, humans need to survive somewhere else. If the filter is behind us, we beat the odds. Now we need to build something lasting. We still don't know the answer. Where is everybody? Are we alone? Are we first? Are we rare? Are we being watched? Are we about to face a filter that stops almost everyone? We're looking, we're listening, we are building better telescopes, we are sending probes to other planets, we are learning more every year. Maybe someday soon we'll find a signal. We'll discover bacteria on Mars or under the ice on Europa. We'll detect chemicals in the atmosphere of a distant planet that could only come from life. Or maybe the silence will continue. Maybe we'll realize that we are special, that Earth is special, that life is more rare and precious than we imagined. We are part of something much bigger than ourselves. We are part of the universe's attempt to understand itself. Right now, as far as we know, we are the only part doing the understanding. That makes every human life valuable. It makes our survival critical. It makes our future among the stars not just a dream, but a responsibility. The universe is waiting. If you enjoyed this video, hit that like button and subscribe for more deep dives. Let me know in the comments, are we truly alone in the universe? What do you think is the answer to the Fermi paradox? Thanks for watching. I'll see you in the next one.